Bigger is not always better, but here's something that starts small and gets better as it gets bigger. Just light it up and see. A team led by Rice University chemists Christy and Stephan, both associated with the Smalley-Curl Institute, have made hybrid particles that combine the unbeatable light harvesting properties of plasmonic nanoparticles with the flexibility of catalytic polymer coatings. Their work could help power long-pursued plasmonic applications in electronics, imaging, sensing and medicine. Plasmons are the detectable ripples of energy created on the surface of some metals when excited by light or other input. Nanoantennas are microscopic bits of these metals, like gold, silver and aluminum. Because they are sensitive to specific inputs depending on their size, shape and type, they are tunable and therefore useful as sensors, bioimaging agents and even as therapeutics. The goal of lead authors Emily Searles, a chemistry graduate student, and Sean Collins, a former Carl and Lillian Illig postdoctoral fellow at Rice, was to create hybrid nanoantennas with maximum energy transfer from their metal cores to a polymer coating. They found a way to coat gold nanoparticles on an electrochemical support with a light-sensitive, nickel-based polymer. When triggered by light, energy from the gold's plasmons flows into the coating while the applied potential in the electrochemical cell induces new polymerization from monomers in solution, doubling the coating size. The resulting hybrid damps light scattering from the plasmons by transferring energy into the polymer shell. The hope is that because we have put the energy in the polymer, we can now harness that energy to react with other molecules on the surface of the soft interface, Searles said. There are no reactions included in this paper, but that's where we want to go. The study appears in the American Chemical Society journal ACS Nano. The gold polymer particles studied measured about 35 by 85 nanometers before polymerization and twice that after. At their peak in experiments and simulations, they delivered 50% efficiency in transferring energy from the nanoparticle to the coating, 20% better than the previous benchmark. Experiments involved putting individual coated particles on an indium tin oxide electrode under a hyperspectral dark field imaging microscope to record their scattering spectra. The researchers knew of two possible paths for transferring the light energy between metals and the polymer coating: charge and resonant energy transfer. These new hybrids, exploiting energy transfer paths, could solve two current challenges with plasmonic photocatalysis, Link said. First, efficiencies are often low because charge transfer is slow in comparison to other competing processes. Second, charge transfer usually requires a sacrificial counterreaction or the catalyst is poisoned over time, he said. These energy transfer-based hybrids eliminate the need for a sacrificial reaction because both electron and hole transfer occur simultaneously. The first challenge was figuring out which polymer was best for getting energy from here to there. The nanoantennas and the polymer look very similar if you simply measure the light spectrum they absorb, said Collins, now a lithography process engineer at Intel. However, they are actually absorbing the light in completely different ways, and the trick is getting those two mechanisms to work together. The nanoantenna casts a huge net to pull light energy in and shares most of the catch to the hungry polymer, giving the polymer far more energy than it could ever harvest alone. The team determined the plasmonic resonance dipole in the gold and the electric dipole transitions in the nickel polymer. The energy in the polymer dissipates after a while, but it doesn't appear to return to the gold, Searles said. The polymer coating does reach a point of diminishing returns, she said. We found there's a kind of a happy place where you're not going to see any more energy transfer, Searle said. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.